Okay. So I think most of you already applied for the Google account, and I think most of you already also joined the Google Classroom. So yeah, I will say one more time. Okay, I'll say one more time. So you need to apply the Google account, and you can join the meeting directly without any. Because usually, if you join outside from the Google Education account, you need my permission to get into the class, right? So if you think that for today's class, if you are still you need my permission to join the class, so it means that you haven't applied or you need to change your account to the Google Education account. Okay, so I hope you can do it this week. Okay? Google account. So Google account basically your account will be this will be your student ID B11 at gapps.ntust.edu.tw. This will be your account. So from this account, you can join the Google Classroom I already prepared, and also join the meeting Google Meet directly join. So please uh, apply for the Google Education, and also you can get cloud storage. I'm not sure how much storage you can get, but I think it's quite a lot. All right. Okay. For today's class, actually, we're still in the um, still following the early chapters in textbook. Last time we discussed the equation, how to solve some problem, algebraic problems, how to take the quadratic equations, how to solve, how to factorize, how to make a standard form, complete the square, and also a quadratic formula. All right. Yeah, looking back here, this is the our discussion here, the quadratic formula, and then some examples here. Yeah, I think this is a good example for you to solve. I hope you try and solve the question, uh, not looking my answer, but try to solve the questions by yourself. Okay. Okay. So still related to equations, I will go to actually my whole part for today will be about inequality. But before I'm going into the inequality, let me just take some small sections about a complex numbers. Okay, so let me take a small section about the complex number. Okay, so basically the numbers you have or you have studied, you have the natural number, you have the integer, you have um, the rational, the irrational, and then you have the real number, right? And apart from all this, so if you talk about real numbers, the number real is actually all this plus the irrational one is basically a real number. But apart from what we have learned or we have known as a number, we have also a complex number. It means it doesn't real. It doesn't real. So if we are, but it's there, but it's not a real number. Okay. So if this is real, outside of real would be the complex number. Okay. So let's take some a simple definitions. Okay. Maybe you start from example. example, if I have this, if we try to solve these equations, if we want to find the x, we want to solve the x, we will get the x is actually, we'll be having this, right? And eventually, when you try to square root both of this, we will get plus minus. And of course, if you are looking at the real numbers, or in terms of, usually in calculus, we are solving in the real numbers, and we say that they don't have solutions for this. That's in the real numbers. But if we take it to the complex numbers, we need to define a new number. So we need to define a new number. So in this case, the problem here is actually, if we are having, for example, square root of 4 plus minus, we can go by plus 2 minus 2, right? Easy. But because of the negative part, okay, inside the square root, because of this negative part here, we need to define a new number. We need to define this. Okay. So this is apart from the whole square root that makes not real. Okay. So we call this imaginary number for I. Or we can also say I squared is -1. And we call this a complex number system. Okay? Complex number system. So this is expression. It's a form A plus B. Okay. Where A and B are both real numbers, and I squared is equal -1. And from this A plus B, okay, we have the real part is A, and the imaginary part is B. Okay, and we can also say two complex numbers. If you want to compare two complex numbers, we can say they both equal if and only if their real parts are equal and their imaginary parts are equal. Okay. It's the official definition is quite long, but I believe this is the important thing here. So we will have A and B, BI. So if you look here, this is the real part, and this is the imaginary part. Okay. Right. So a complex number system, it can have, for example, um, 2 plus 3i. So this will be the real part. This will be the imaginary. So this is real. This is imaginary. If I'm having um, 5i, so it's only having imaginary part. And real part is 0 for this case. Or sometimes we also call this, when they have only imaginary part, it's pure imaginary number. All right. Okay, by the way, the lecture for basic math, we will still have online lectures for the whole semester. Okay, because I believe if I hold an offline class, um, I'm not sure it will also going to help you or not, but I think because most of you are coming in, I think November, I don't think offline classes will be helpful. Okay, that time, so I will just make the whole classes online, and for the final exam, although we can apply for offline classes, but I think for basic of math, because I will have some PBL part later on at the end of the semester. I think we still have a better part for online exam. Okay, I'm still thinking about the platform, but I hope I can make it to official announcement. Okay, how we can do the entire exam and also do some project with you. Okay, and you can try to look for and discover some project, but I will tell you and explain in details later. But yeah, that's for now. Okay, for the classes. So the entire classes, the whole semester will be online lectures. Okay. Okay. Okay, let me continue a little bit about some operations in a complex system. So we can have arithmetic operations on a complex number. Okay, for example, if we add, for, let this be a complex number a plus bi, and also another complex number c plus di, and we want to add both of them. So the idea is quite simple. You can add the imaginary part and real part. Okay. Subtraction also similar, so I will just make minus there, so you can plus and minus in the same manners. Okay, that's for the addition and subtraction. How about multiplication? So we can also multiply. So we can multiply. I think it's the same way, but you need to group uh, all the real parts and the imaginary part at the end of the results. And also, uh, if you have division, how to defining a complex number. So we need to do something before you can define the complex number. So let me write to simplify the quotient a plus bi divided by c plus di, and to multiply the numerator and denominator by complex conjugate. It's similar with the rationalize. Let me show you how. Okay. So if you have a plus bi and c plus di like that, we can multiply. Let me write one more time here and multiply the conjugate. The conjugate will be c minus di. Okay. Why we need to multiply with the conjugate? Because we want to make this denominator here, right below here. We want to remove the imaginary part. Okay. Because if you have a plus, let me write here, a plus bi, and you want to multiply with a minus bi, it will be a squared plus b squared without any imaginary part. So this part here will be, okay, so c squared plus b squared, and this will be ac plus bd plus bc minus a. Okay. Okay. Some conjugate, if you're still confused about what conjugate means. For example, if I have 3 plus 2i, the conjugate will be let me write a table like that. So example and conjugate. This will be 3 minus 2i, 1 plus I minus 4i. And what about just a number there? Let this be just a number in the conjugate. Okay. Okay, any questions first? I think maybe we can try to give you some example. Right here, example here. Okay, the question is just expressed in the form of a plus bi, meaning you need to remove the fractions. So for example, we have two questions here. So 3 plus 5i divided by 1 minus 2i. So we need to remove the denominator. We need to make the fractions here becomes a plus bi. Okay. So first thing we need to do is we multiply with the conjugate. Okay. The conjugate on the denominator. So of course, the first one we multiply with so 1 minus 2i multiplied by 1 plus 2i. So it will be 1 plus 4, right? Okay. So it will be 5. 5i plus 6 plus 10. So it will be negative 7 plus 11. Or we can write negative 7 over 5 plus 11 over 5. Okay. If you're still confused how we get the negative 7 plus 11 is actually you just one by one multiply and then you add all of them. Okay. Okay, the second one, we need to multiply with the conjugate, which is the negative 4i. And we get the 12 divided by 16. Or we can write this is 3 over 4. So this is what the questions means. Okay? So we need to make the form a plus b. So a plus bi. A plus b. Okay. Okay, let's move on. A few more, and then we can move to the inequality. Okay. Uh, this is about the square root of negative number. So r if negative r is negative, then the principal square root of negative r is the two square roots of negative r, there will be the positive and the negative. I think this is quite simple. For example, if you have 16, negative 16, before I and negative 4i. Okay. Okay, another one is complex solutions. This is the last one on the complex numbers. So complex solution on or of the quadratic equations. So x squared plus 9 is 0. So it means we have x squared equal negative 9. So we will have x is plus minus square root negative 9, and we will get plus minus 3i. Okay. Second example. So if you look here, what will happen now? You can do the complex solutions, or try to factorize if you cannot. Maybe try to complete the standard form. I think this is not too difficult now. If we have this, sorry, and we can from the equation you can see that it has the negative 1 here, right? So we can get actually negative 1. So we can have plus minus I, or you can do directly the quadratic formula if you want. Okay. Okay. I think that's all for the complex numbers. Okay. Because all the idea is still the same. The difference is on how we find the solution, which is they are includes the imaginary part on the solutions. Okay. Then let's move on to inequality. Okay. So equations, we've done some of examples. Now it's complex numbers. I will add more, maybe some questions later to the Google Classroom. So make sure you join the Google Classroom. Okay. I will maybe put the invitation link later on the Moodle, and you can join. I think some of you already joined. Let me check. We have 6 students joined now. So I hope everyone can join the quiz. I will put the link later. You can check the Moodle. Okay? or maybe I can uh, I can give you the link now. That's the link on the chat box here. You can save the link for later if you want to check out, or you can click, and then if you are using the Google Education, the G apps, you will directly join to the Google Classroom. Uh, there's still no announcement for the Google Classroom. I think today I will maybe give you some announcement maybe later tonight. Okay. Okay. Any questions first before we move on to inequality? Okay. If there's no question, then okay. Let's move on to inequality. Okay. Okay. And now inequality. Uh, so basically, we learned last week the equation how to find x, exactly x, right? Like for example, you have a linear equations like this one. It's quite easy. What you need to do is you need to solve and then finding the x, right? To solve, go here and divide all by 4. You get x is equal 3. It's quite easy. But what will happen if you change the equal sign, become less equal like this one? So it means that the answers is not exact one answer, right? If we want to draw in a line number, let me move this a little bit left, and let me draw this line number. Maybe from 0, 0, and then maybe this is 3. Okay, the first one, we only have 1 point. So this is exactly our solution. Okay. But in the second case here, 4x plus 7 is less equal 19. So if you try to solve, and similar like what we have done in the equal one, in the first equation, we will get it's, or I mean right here, which means that you have from 3 here, you get all the answers from anywhere behind until number 3. That will be the answer. Okay. So to solve an inequality, you need to find all possible answers. Okay, not just one. But to solve the equation itself, you can solve as it is the equal sign. Okay? Just to make, or just to find the point. Okay. Later on, I will explain to you why I'm saying that. I'm saying that. Okay. Okay. I think it's for linear inequality. Okay, let me try and check your ability. I believe you can solve this, because if we are still in linear inequality, which means it's not really that big deal or a complicated one compared with the nonlinear one, which usually contains complicated solutions sometimes. Okay, can you solve this? Or it is too easy for you? Is it too easy? I think you mix 2 and 3 should be, I think, 2 over 3, right? Yeah. Okay. I think this is quite easy. Is you still uh, you can still use like in an equal sign, right? So which means if you going here, still be like this. And if you multiply with the negative part, all these things, you make it all negative. So it will be 6x. Okay, and then divide by 6, it will be, okay. So careful when you have this less, and then you have negative x, okay, like this one. If you want to multiply all by negative, then this less will be changed into greater than. Okay, all right. If you have 4, what will be the solution for this one? So you have it's called simultaneous inequality. This is just a linear inequality to left one. Oh, careful design. It has the less equal. Yeah, basically it's the same thing as before, but you have more. So this is the middle one, right? So if you want to add, you need to add both sides here. Okay. For example, let's add +2. So +2, +2, and +2. Okay. So it will be 3x. And then divide by 3. So it will be x. Okay. Okay. I think for linear, like this one, a linear inequalities, or we have simultaneous inequality, but it's linear one. I think it's still doable, not really that complicated one. Okay, what if let me write in the okay, let me example x squared minus 5x less equal -6. Mm-hmm. Okay. So x less than, is that negative or equal? Equal, right? Less equal 3, x less equal 2. Hmm. So if I say x less equal 3, okay, now it's getting interesting, right? So this is what most students make a mistake because of this signs here. Okay, anyone find the answer? Anyone? I want you just to know how you are dealing with these situations. Yeah, that's the answer, Scarlett. Yeah, that's the answer. But sometimes, uh, because of the inequality, you make mistake. If the question is, for example, if the question is just this, okay, let me try in an equal sign, okay. Okay, I have this, right? I can deal with it, factorize easily, right? Okay, now your answer still have the same 2 and 3, right? It's also same 2 and 3 in our answer here in equal sign, okay. Get you get it? So the idea is, okay, this is actually my my preferable solutions, or my preferable method. Okay, I hope you get my idea. So I find this x equal 2, x equal 3. All right. Now I will draw a line number. Okay. I draw a line number. I will put 2 maybe here and 3 maybe here. Okay. And then what I want to find is I need to make this less equal 0. Okay, the whole equation here. Okay. So I need to pick up some numbers. Okay. To pick up some numbers. So maybe numbers here are maybe 0 or 1. Okay. Numbers from here maybe 4. Numbers from here maybe 2.5. Okay. But at least some numbers that you can expect to be counted, to be calculated. Okay. So if you put 0, okay, if you put 0 or 1, maybe just 0, I think easier to be 0. If you put 0, it's become positive, right? You put 0 minus 0, right? So it's plus 6. It's positive, right? Okay. If you put 4, let's say 4, it's 16 minus 20 uh, plus 6. So it's positive, right? It's plus 2. Oh, it's positive. Good. Of course, if you put 2 and 3, it's become equal 0. So it's going to be included inside, right? And what will happen when we have 2.5? 2.5, 2.5 squared minus 5 plus 6. What will happen? I think we can write this as 25 over 4, right? It is 50 over 4. It's negative 25 over 4 plus 6. It's actually if you look here, it is negative, right? Negative something. I don't care about the number, but I know it's negative, right? From the fraction here, it's greater than +6, so it should be negative, right? So the whole thing here is negative. What are we looking for is less than 0, which means we need to have equal 0 or negative, right? So we need to find a negative one, including the one that makes 0. All right, do you get my logic? So this is our answer. Okay, and my method here is applicable to all nonlinear equations. Because if you look on most of the textbook on math, they will make some long explanations, and I don't think it's really practical for you, I think. But if you think that is a good way to learn, then that's okay. I just think that for example, you have make the table first, right? You try the interval from, but is this is the same thing as we have done here, and try this interval, and then this is for x minus 2, x minus 3. You try several. It is actually what we have done in the line number. Okay, and then you try to make which one is positive, negative, positive, right? And write down here the signs, and then you can make some conclusions, and then the conclusion is the answer should be this. Okay, but my method here, my preferable method, is every time you have inequality, you treat as an equal first. Finding the point, which means finding this x equal to x equal 3, put in the line number, and then put your goal. Put your goal. This is your goal, right? You need to make out these equations to be less or equal 0. Okay, and then to find out which interval we are, we can put the number. Let's say 0, 1, any number that you can think of that is easy. Yeah, why is negative? Of course, you need to calculate. I think I already told you, right? It's negative. So you get here, this part? Okay, let me erase one more time if you don't get it. Okay, between 2 and 3, what number that you can think? You can get 2.1, 2.2, 2.3, but I think that will be difficult to count it, right? I will try 2.5. Okay, let's try 2.5, or 2.5, you can say it's 5/2. Okay, so let's say we have x squared, our questions, negative 5x plus 6. Okay, let's put in. Okay, let's put in. So 5/2 squared, negative 5 plus 6. Okay, we need to calculate what this will be. Okay, this will be 25/4, negative 25/2. Okay, 25/4. This will be 25. It's become 50/4. I will multiply by 2 so that I can calculate it. So it will be negative 25/4 plus 6. Okay. Is it positive or negative? Helen, is it positive or negative? Yes, that's why it's negative. Okay. You get it? Okay. So that's why I conclude that my solution here, the interval from 2 to 3 is negative. Okay. And 2 and 3 are positive. If you put 2 and 3, what will be? It's equal 0, right? We already done here. So x and 3 is the one that makes 0. That's why the answer for this one is this. You need to include 2 to 3, but the number 2 and 3 need to be included in the interval. Okay, right? If the questions, for example, if I change the questions become x squared negative 5x plus 6, and then it should be like that without any equal. So the answer should be, but the whole process here, it will be the same. Okay? It will be the same. Okay, let me get you to maybe example. Okay. Let me give you maybe one example, or maybe 2 more examples. Solve the inequality. Let me look for the questions first. Okay, maybe first is x squared. First one is that, and the second one is 2x squared plus x. Okay, 2 questions. 2 questions. Okay, try to check whether you can solve it or not. Okay, for the first one, what is the answer? Negative 3 less equal x is equals 6. Yeah, good. Okay, good. Okay, so again, it doesn't matter which inequality you have, but in my preferable method, I'm just make it into an equal sign first. Okay, and I think this is maybe maybe my suggestions. Like if you're in panic situations, like like you're very nervous, maybe it's your exam, and sometimes your thinking um, can be mixed up with other things, right? And this inequality, because it can be less equal, greater equal, or less or greater, and then maybe you mix up with positive, negative, right? So to minimize mistakes, what I want to suggest to you is make it just an equal. Let's look for the if you can factor it, you can factor it. Just make it equal 0 first, okay? So your mind's still on a clear path, okay? And you're still looking the, okay, I think I can do it, okay? So this will be -6 plus 3, right? Yeah. And you think that, oh, I get it. I think this will be my x to make it 0, okay? And then, because it's inequality, you put into the line number. So you put -3 and 6 maybe here. And then maybe thinking some number that are in the middle, and then maybe below 3 or greater than 6, and then put out into the equation. And your goal is to make this less equal 0. So you need to find out which interval is positive, which interval is negative, okay? So maybe we tried, maybe here is -4. So we put into the equations, -4, careful, negative and positive, negative, negative, okay, careful. So it will be positive, okay, and it will be positive, right? It's resulting positive, so it's positive. Okay. And let's try with the other number for the other interval. So from -3 and 6, we try maybe 0. So 0 it's negative. Okay. And try 7. I think 7 will be positive too. Right? It's 49. Still yeah, still positive. Okay. And then -3 and 6 is a number that makes the equation 0, right? So it's included in this in the answer, and we want to make less than 0, less equal 0. So it's going to be -3, 6. Okay. I hope that's helpful for you. Okay, the next one here. Well, we have okay, so all right. X. Okay, good. Yeah, x greater than or equal half. Yeah. Okay, again, good answer. Okay, again, this will be pretty much similar way with what we have done. Okay, so 2x squared plus x. Let me make this is -1 and try to make the equal sign. Look at the regular equations here. Okay, and probably we can factorize and try to take on some number. And my suggestion also, if you have this factorization, you can try to make out this table. Okay. And by the way, this is quite helpful if you are in a stress or stress environment. You cannot, your mind cannot be relaxed, like maybe an exam. Because if you try to make out the factorizations like in terms of this, and then you try 2x. Sometimes you are miscalculated to make, and when you make a table like me, like this one, you can minimize your mistakes. Okay, it doesn't guarantee this will be successful, but at least it can help you to relax your mind and minimize any mistake. So first, 2x, it can be factorized, maybe 2x multiplied by x, it becomes 2x squared. And negative 1, yeah, it's around 1 or negative 1, or it's the other way around. Let's try. Multiply this, negative 2 plus x, it should be negative, right? So we can switch these options. So I think this is correct. Now, when we cross multiply, 2x minus x, it becomes plus x, so it's becomes true. So your solution will be this. And you have 2x equal 1, so x equals half, x equals negative 1. Okay, and then going for line number. And then you need to take out, or your goal is to make this to be greater than 0 or equal 0. So you can maybe try from the left side first, negative 2, maybe negative 2. I try out. It's become positive minus 1, it's positive. Okay, you don't need to calculate to the exact number. As long as you know that it must be positive or negative, that's still okay. And maybe try the middle one here, maybe 0. You can see it's negative, 0, 0, and negative 1, right? And try maybe 1 here. It's positive. Right? So the one you're looking for is the greater 0. So it will be here and here, and it need to be included negative 1 and half. So you can write the answer. Or if you want to write in interval, that's also fine. You can write from negative infinity until negative 1, but need to be included. Okay. And then you can write from half. Okay. All right. Any questions? Any questions? Okay, if there's no question, let me move on to another inequality, another section. Okay, move to here. Okay, can you try to solve it? Okay, I'm giving you a few minutes to try. Okay, do you find the answer? Mm-hmm. All right. Okay. Any answer aside from Ardian? Mm-hmm. Oh, yeah, you really did good job, Scarlett. Good. All right, this is probably what you're thinking. Uh, it seems simple, right? Maybe you're thinking to multiply this with this, and then you make this, maybe, right? And it's becoming simple, right? You have 2x, maybe x, maybe this, right? But what you need to do is actually, let me write one more time here. So don't do this, right? You know why? Because you have this fractions 1 minus x as your restrictions, okay? Okay. Let me write here. So the solutions is basically to solve and make the fraction still a fraction. Okay? So let me write here. Let's try to solve step by step here. Okay, careful here. So 1 minus x multiplied by the negative, it will be negative 1 plus x, right? And you get this 2x. Okay, we have now a fractions. And from this equations, we have our restrictions, right? We have our restrictions. Look at this 1 minus x. 1 minus x cannot be 0, right? So x cannot be 1. That's the directions. So you have at least 2 points. You have 0. You have, oh wait, 1, right? But I think 0 is still okay, and it's make the equation 0, right? So it's included, but 1 is not included. Not included there, right? And then what you can do now is still same or similar method with the previous one. Your goal now is this 2x over 1 minus x. They need to have positive or 0 solutions. If you have a negative, maybe negative 1, plug it here, you have negative 2, divide by 2, it's negative, right? If you have maybe 2, try 2, it's 4, it's negative. It's also negative. Maybe in the middle, the fractions, maybe half. become 1. 1 minus half, it's positive, right? And we want to make out the positive, right? Or 0, right? 0 and positive. So we will have this. So that's why you can write the solution in interval, including 0, but not including 1. Or you can write 0. Okay. Any questions? Okay, any questions? Okay. We still have one section about the inequality, and I can move on to a little bit information about the one sections. It's about circle equations, but just a small review. Okay, the next section is it's absolute value inequality. So if you have this, then this means that you can have x in its negative form and x in a positive form, so it will impact the number that you are evaluating. And if this is greater than c, then this will be or. Okay. Okay. I think it's better to just go to an example of absolute value and see what we can do from this example. Solve Okay, to solve this, based on what inequality we have, we can have x minus 5 as a positive or negative. So we will have this inequality. And we can solve this plus 5 plus 5 plus 5. So we'll have 3. And that will be our solution, our interval. The second example, if we want to write, let's say, first one is this, and the second one is constant negative. And the solution, yeah, this is the solution, or you can write the interval. It's included -2, union 2 over 3, and then going to infinity. Okay. All right. Yeah, I think absolute value. I think that's still okay, right? Okay. All right. Yes, we have done this, I think. So we can skip this. Is also we have done. Let me skip that. Okay, the next section is actually, it's called the coordinate plane. Including the circle, distance. But I think most of you are already familiar with the coordinate plane, right? Maybe just a review, small review. Distance formula from 2 points of coordinate plane. Distance. So distance so if you have 2 points in the plane, you can write. Usually you write with D, small letter D, and A, B, the point you are going to observe, and then square root. And basically, this is so why you are writing like this, because if you look at the plane, let's say this is A, this is B, two different points, right? And this is the distance. So basically, the easiest way to look the distance is from this triangle. Okay. This is, you have the delta x, this is the delta y. Or y2 minus y1, this is x2 minus x1. And then you use Pythagorean theorem, okay, to find this L. L squared is and that's how you find the distance formula here. Okay. And how to find the midpoint. So you find the distance, how to find the midpoint. The midpoint is here. That's the midpoint. It's basically half part of the x and half part of y, right? You can say the midpoint so every time you heard midpoint, maybe in basic math, in calculus, you heard midpoint, it means that the point at the middle of something that you observe, okay? Okay, intercept. No, you already. I think you have. Okay, maybe going for this circle equation. Okay, let's move on. Sorry. So circle. Okay, let me draw. This is the center. Let's write C, and we have a point here, point P. So this, and the center will be right. Usually it's written H and K, the center, and you'll have the radius here. Right? Okay, so if you look P, point P, we can say P is on the circle if and only if the distance from P to C is equal to the radius. So we know from the formula, the distance formula from the previous one, if you look at the triangle here, then it should be square root of x minus h, the delta x, right? Squared plus y minus k should be equal to r. Okay? So this will be the x minus h. This will be y minus k. Okay? And then we get the formula for the triangle, the Pythagorean formula. And this is what it looks like. And usually we write in terms of r squared instead of r. So this is our equation of circle. So let me write here an equation of circle with center h, k, and radius r. Okay. If the center 0, 0, then equation of circle, it will be x squared plus y squared equal r squared. Let me write this. Okay. All right. So if you observe an equation of circle, for example, let's say example, you have x squared plus y squared equal 25. So we know from what we have written here, the center will be 0, 0, and the radius is 5 because it is r squared, right? Okay. If we have x minus 2, squared. This means that the center is 2 and -1. And then we have the radius is also 5. Okay. And I think you can also draw that if you want. The same proportion of circle, but different center, right? The same circle with radius 5, right? But it's in different position, different center position. Okay. Okay. We can also write this equation here become an expanded form. Okay. So x squared, let me just make it into expanded form. So expand both x and y. And solve all. So x squared plus y squared minus 4x plus 2y equal 20. So we can also write the equations like this. So we can have two different forms, okay? But the same circle, the same circle. So this is giving you an idea. If you get x squared plus y squared plus 2x minus 6x, 6y plus 7. And then show that this is an equation of circle. Find the center, find its center, find radius. Okay, now from this part of equation here, if you look back here, we can definitely going from this, the left one here, and going back to the original one. Okay, and we can use the complete square, to complete the square. Okay, so first we group all x and all y, each one. So x squared, let me write x squared plus 2x. Okay, and let me give a space here, and then plus y squared minus 6y, and then I will move -7 to the other side. Plus 7 become -7. Okay. So the idea is, remember, to complete the square. Okay, so you are having this is 2, divide by 2, you have 1, and then it's squared, so plus 1. This is 6, divide by 2 is 3, squared is plus 9. Okay. So you need to plus 1 and plus 9, so you need to plus 10 at the other side. Okay, okay, and then this become x plus 1 squared. Okay, and the y one will be y plus minus, and then it's equal 3. And you see here, this is an equation of circle with center -1, 3, and radius is square root of 3. Okay, the radius, of course, radius, it should be positive, right? All right. So that's a little bit review about the circle. Any questions or any discussion or anything that maybe you probably a bit confused? Okay, there's no questions. Let me give you another small section. So with circle done, I'm going to have a little bit discussion about the symmetry. We start by looking at a simple graph. Okay, let's say this is the graph of y equal is x squared. Okay. If you look here, and I think I'm not really making it symmetrical enough. Okay, let's look at this graph, and you may notice that the left side of the graph it's mirroring the right side, right? So we call this is the symmetry. So we'll see that this is practically the same distance from there. If this is point x, y, this point, this is negative x, y, right? This is reflected each other. Reflected. Let me just write reflected first. We can say the graph is symmetric with respect to y-axis. And we can also have, this is when we have this kind of point. We can also have the one with y. So this is the graph is symmetric with respect to x-axis. Yeah, maybe I will show you the example here. Okay, let's say that's the graph. So we have this symmetric here, and this is the point. And then we can also have, okay, we can also have a graph like that, in which this is actually also symmetric. the symmetric. So let's say this is xy, and this will be negative x, negative y. So we call this, the graph is symmetric. With respect to the origin. So it's reflected to the origin, to 0, 0, okay? Okay. Now, how to test whether it's symmetric or not? Okay. For the first case, respect to y-axis, we can replace test. Replace x by negative x. The second one, we can test, replace y by negative y. And to test the last one, we can replace x by negative x and replace y by negative y. Okay, let me give you the example. Test equation test the equation for symmetry. So of course, if you look at the equation, it has a cube, right? X cube. And if you know the behavior of the cubic formula or cubic equations, it will have a symmetry on the origin, okay, because it has this kind of graph, right? So we can go certainly for trying the replacing the x with negative x and y with negative y. So we try replace with negative y and then replace with the negative x. And then we can multiply by negative 1. And we are going back to the original one. So which means that the graph is symmetric with respect to origin. And you can also try to look the graphing calculator or the GeoGebra and try to put the equation and look the visuals. And I think you will get something like this. Okay. All right. Okay, any questions? Any questions first? Okay, if there's no questions, we can go for a feedback time. For tomorrow, actually, we will go for review line equation and yeah, probably mostly line equation and maybe some exercise. And then next week we can move on to the chapter 2, which is the function. But because we already learned a little bit about function, I will just make a quick review for functions and maybe point out which one that is necessary for you. Okay. If there are no questions, so it's now feedback time. So please scan the QR code. Oh, I think, oh, sorry. Let me, why it's different now. Let me change the, okay, I think this is probably correct. Okay, please join the time. And probably at the end, or maybe, yeah, maybe third week on October, I will find maybe we will have some quizzes. Okay, I will announce later. Okay, please join. So if you have troubling getting in using the QR code, you can go to the website instead. Go to menti.com and use the number 57115328. Okay, 6 students already in. We have 9. So where's the other 3? Yes, we have 9 students, but there are only 6 students joining. Okay. Can you type in the chat box of the Google Meet who are joining the feedback? One of the students. You can say it's me. Yeah. Can you type in? Okay. Okay, good. Oh, you're doing? Okay. Okay, then I think we can start. Okay, we can start. Okay. Okay, I will start. 3, 2, 1. Okay. You need to answer fast. Okay. Well, 30 seconds. You need to thinking fast. Because the answer is already there. And just think of 3, 2, 1. Okay. Okay. All right. Okay. Next question. Okay. All right. Okay, get ready. Okay, 32 seconds. Let's try to answer fast. 3, 2, 1. Okay. Okay, good. Yeah. Okay, congratulations. Correct. You win the game. Okay. Yeah, okay. If you collect maybe more than 2 or 3, I'll prepare a gift for you. So I will calculate all the total. And the one who are join the quiz and maybe get some points, you also get some points for your bonus activity. Okay. Okay. I think that's all. Okay. Uh, so never give up. Never give up. So try to if you haven't tried, like in math, some examples, some problems, you need to try at least by yourself. Okay. And probably I will, maybe if not today, maybe tomorrow, I will have some announcement on the Google Classroom about some assignments. Okay. I'm still using the Moodle for just a regular information, but for more for assignments and homework, and also maybe quizzes, maybe in the Google Classroom, I will announce. Okay. So please join the Google Classroom. Okay. Um, I'll probably email first because my line I need to add the context because I don't know the line is sometimes it's not really good yet. So preferable just email me. Okay. Okay. If there's no questions, we're done now. So you can leave the Google Meet. Yeah, I know. You cannot join because you are not using your G apps. So you need you use your G apps account. Do you know how? I already mentioned several times. Yeah, you can change your Gmail account and then change to your G apps, and you can click the invitation. Yes. Okay. 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 See you. See you. See you.